Okay, first of all, the order is a big deal. Trying to decide whether the order matters or not, it can be really confusing, believe it or not. If the order matters, I have been saying order patters just to annoy you into remembering that the P is the one where the order matters. Okay? So a permutation is the one where the order matters. Yes, you can use blanks, like, 8 times 7 times 6. There's 8 choices and 7 choices and 6 choices. Um, if we did one that had 3 blanks and 3 things to put in there, that would be a situation like, let's say I had 3 books and I want to put them on the shelf. And one book can go here, one can go here, and one can go here. Well, then I have 3 choices times 2 choices times 1 choice. There would be 6 different ways to arrange those books. In that situation, the order matters. All right. Now, yesterday, I had you do these by hand versus, and I will do a 2-second review for you, but pay attention because you're going to be responsible for this in just a moment. Okay. Here's a reminder. 3 factorial over 3 minus 3 makes 0 factorial. What is 0 factorial defined as equal to 1 is correct. All right. On to the next kind. This one was 3 factorial over 3 minus 3 is 0 factorial. And then there's an extra one on the C's. That number again. And so if you have, see how those would cancel? Does my answer mean 0 then? 1. That's correct. Because they really replace with 1. The answer for that would be 1. What would that be like? That would be like there's 3 books, and I'm going to choose, I have 3 spots to put them, and you can either do it or not do it. It's just, there's one way to put them up there. You just put them up there. If the order matters, and I'm doing this, and then if the order matters, it's 3 times 2. There's 6 ways to put them on the shelf. If the order doesn't matter, then I just put them on the shelf. And the answer is 1. You get the difference? Order mattering, order not mattering. Answer 6. Answer 1. All right. Now let's go on to this. How do you know if it's a permutation or a combination? These are some of the key problems we usually use. If you pick a group or a committee, then you don't care about the order. I'll give you a couple others that they didn't use. Pizza. Why? Because do you think you really care about the order when you're ordering pizza? You'd say, I want the cheese first. Then I want this other kind of cheese put on there. And then I want the pepperoni put in. You don't tell them what order to put in. Next one, for permutations. That's order, and I am going to put another one. Any competition where there's places, then you need to have a P, or permutation. Order will matter. Okay, moving on. You should be on the Chipotle page by now. Chipotle, meaning it's got a lot of choices for how you make your burrito. In fact, they had a little promotion running for a while, like, how do you want your burrito? Or what's your favorite kind of burrito? So, as we think about Chipotle, it's not even close to the middle of the day yet where you start getting really hungry, but I know most kids tend to like this place. Is there anybody in here that has not been to Chipotle? I'm curious. So every single kid's been to Chipotle. All right. How many of you have been to Chipotle? Has to be more than 10 times. All right. That's like, I'd say at least half the class has been there more than 10 times. All right. I know one kid who seriously goes to lunch like every other day. They have lunch there. Go to a private school. That's how they roll. Anyway, let's talk about how you can make yours. If you had 2 different toppings. Now, some kids said, you can't have chicken and steak. Oh, yes, you can. It just costs more. It costs you $2.50, I think, or 2 1/4 to get extra meat. So you can get two meats if you want to. And it'd be kind of weird. Most people get like lots of toppings. You usually take kind of what they put on there. It's some rice and some beans and some, some of the. What's your favorite kind? Do you like chicken? Do you like beef? I'm a barbacoa guy personally. Who else is barbacoa? Oh, barbacoa is the beef. It's like a spicy beef. And it's not like super spicy, but it's spicy enough. It's kind of like the steak one a little bit, except the steak's obviously more chunky. It's steak instead of the shredded beef one is my favorite. Anyway, so if we have, how many burritos can we make with exactly 2 different toppings? Well, we have to know how many there is to pick from. And there's 11 if you add them all up. Or 11 things you can put on Chipotle. So you got 11, choose 2. Make sense? All right. Now, how many burritos could they make with 3 different toppings? It's just 11 through 3. That's all there is to it. All right. Do you think there'll be less or more? If I do 11C3, do you think that'll be more or less? I'll be your calculator for you. There's 55 and you do 11C2. There's 165. Do 11C3. Why more? Because now all of a sudden adding in a different topping, like plus you have sour cream, makes it a whole different burrito. Okay, so you add more combos this way. All right. Then, let's move on to this screen. There's 9 people in this family, and a group of 3 is chosen to plan the next year's reunion. Well, then they have 9, and they're going to choose 3. Do you think the order matters? Like, you're the #1 committee person? No, it's just a committee. Okay, so this would be an order doesn't matter. On this one, this is the first one where you are going to be stretched a bit, and you need to get to the cookie page. Oh, I know, I know, it's torture. I know. This is a bad time to tell you that we have cinnamon rolls in the math office today. Anyway, okay. So, anyway, not baking bacon today. That's correct. We did that a different day. In my first semester class. Did we actually? I didn't actually make bacon, did I? Oh no, I did. Okay, that's right. That's right. I gave you the choice in that hour because just in case anybody was offended by pork. Anyway, but I had octopus as an option too. So back to 2 chocolate chip cookies. That seems easy, but it's not as easy as you'd think. Especially this part. This is going to be hard. All right, would you please do the 2 chocolate chip cookie question? Read it over. I know yours is kind of all mushed together on your screen, but if you look up at mine, it might read easier for you. A bag of cookies contains 6 chocolate chip, 5 peanut butter, and 1 oatmeal. To the untrained eye, that may look like a complicated number, but it's actually just 12. There's 12 cookies. And you get 2 of them. And so what are you going to do? Come on, what's this? Let's see what. 12C2. That's all there is to it. Okay. Or is there more to it? Let's just grab your graphing calculator. No, it doesn't say probability. Oh, wait, it does say probability. I'm sorry. Grab your graphing calculator, figure out 12C2, and then you'll find out that that's not the right answer because this is a probability question, and that's just going to be a number. 12C2 is going to be handy, though. If you don't have a graphing calculator, borrow one of mine. Rápido, por favor. If you haven't got yours yet, grab it. I have extras in here. I'm sure steal hers right before she gets there. If there wasn't more, I would not let you do it. No problem. All right. 12C2 is part of the question, but it's not the whole question. There's 12 cookies, choose 2 of them, and what does that come out to be? 66. All right, so then 66 is part of your answer. That's all the possible combinations. Remember, the possible goes in the bottom. What you want goes on the top. And they're just wanting chocolate chip cookies. They don't want to pick any other kind. So you narrow it down to only the chocolate chip cookies. And how many chocolate chip cookies are there? There's 6 chocolate chip cookies. And I want to get how many of them? So you go 6, choose 2 over 66. Or 6, choose 2 is what I want. Just 2 chocolate chip cookies. Over what were all the possible things that could happen. I could get 66 different things, and that came from 12 choose 2. So to make it a probability, do you get how it has to be a fraction? Something over something. And do you get that all the possible combinations are 12 choose 2? There's 12 cookies, this, and this, and I want 2 of them. That part should be easy for you. We've done that before. The part that's weird is this top part. I narrow it down to just the chocolate chip cookies. And I just want chocolate chip cookies. So I say how many of them are like that? It's to go 6, choose 2. All right, and you're all said and done. It should be 0.23. Okay, because you divide the 2. And it ends up, I think it's the top 15. Okay, so it's 15 out of 66, which is about 0.23. All right, I know that was a little strange for you. Let's see if you can figure out this next one. 1 chocolate chip and 1 peanut butter. Well, probability, I still have to have the same bottom. 12C2. There's gonna get 2 cookies. Who can tell me what they think the top is? What do you think? There's something about the chocolate chip and the peanut butter, but you don't add them, actually. So, what do I do? 1 times 1? That doesn't make any sense. Okay, so what would the number be for the chocolate chip cookies? 6C what? Nope, I want 1 chocolate chip cookie. 6C what? Times the peanut butter cookies. There you go. Do you get what just happened there? I have 6 chocolate chip cookies, and I want to choose 1 of them. Get it? There's 1 out of the 6. There's 5 chocolate chip. Wait, that was chocolate chips. Peanut butter cookies. 5 peanut butter cookies, and I want to get 1 of them. 5. Choose. And what do you do to your choices? You multiply them. You may have remembered me saying that at the beginning. You can do a lot of multiplying choices in this probability. All right, so what is 6C1? If you knew the little factorial thing for it, from yesterday, you'd remember that it was 6 factorial over 6 minus 1 is 5 factorial with an extra 1 factorial, which is completely irrelevant because 1 factorial is just 1. And then you'd end up with 6. And I bet you're smart enough to figure out what this one is. 5. 6 times 5 makes 30 on top. Over, still 66 on the bottom. And that's just a smidgen less than half, right? 0.45, actually. Try 30 divided by 66 again on the calculator. And here's your problem. Question. Is there a question? It's 30 divided by 66. I was just showing how this part was 6. This part was 5. That's how it makes 30 on top. And on the bottom, 66. All right. I want to give you another kind of a question. Standard deck of 52 cards. All right. To do these card questions, you really have to understand there's 13 hearts, 13 spades, 13 clubs, 13 diamonds. Clubs, spades, hearts, and diamonds. All right. Find the number of 5-card hands that can be dealt. Well, always ask yourself, does the order matter to decide if it's a P or a C? Does the order matter on cards? Well, it kind of depends on the game, but if I just hand you out 5 cards and you pick them up all at once, do you see how the order doesn't matter? I just pick them up all at once? Okay, so that's a C. Then the question next is, what is the total number I can pick from? 52. How many is the total I'm going to get? That's why it's 52C5. There are a lot of different hands you can get. Why is it C? Because the order doesn't matter. Remember, if you pick up all the cards at once, do you even tell what order they were given to you in? Are you like, you've got the same cards, it doesn't matter if you like rearrange them. All right. Now you might know if they're what order they came in, and you might not, but it's a C question. All right, so next, find the number of 5-card hands with 4 cards and 1 diamond. All right, this is where we have to split it into 2 C's. A C and another C, and you multiply your choices. 4 hearts and 1 diamond. This is where you got to stretch your brain. Weird crackling noise. All right. Do you get that there are 13 hearts and I want to choose 4 of them? And that there is 13 diamonds and I want to choose 1 of them? All right. If you do 13 choose 4 and 13 choose 1, you multiply them together, you get 9,295 hands. Pretty insane. The number of hands that you can get dealt is over 2.5 million hands. So if you wanted to just deal yourself hands of cards, you'd have to deal yourself 2.5 million hands of cards to just be able to see all the different combinations you could have had. It's just crazy. There are a lot. All right. Now, what this would lead us to is if I wanted the probability of getting 4 hearts and a diamond, I take this number and divide it by this number. All right. Find the number of 5-card hands with exactly 2 queens. All right. This is not a probability question. It's just how many hands are there that would have exactly 2 queens? I think good question. How many queens are in the deck? 4. So then it seems like it's just going to be 4, and I'm going to choose 2 of them. But that's only 2 cards. I haven't dealt with the fact that I have a 5-card hand. Nope. I need another times put by a C, though. You're right on that. 52? Nope. Oh. Oh, that's right. No, you can't call me out on that. I have set an alarm for myself. Do you know why? Take attendance before you can bust me. Cheating. That's actually just something I should have done in the first place. But anyway, so now I'm going to take attendance quick while you're figuring out this answer. I know it's 4C2. Somebody must have figured out what to do with the other part. Nope, it's not 13. What goes here and what goes here? All things, there's not enough rooms. Kind of like I has cheeseburger. All right. Is there normally somebody sitting behind you? Aha. Other than that? No. Okay. And is there normally anybody in front of you? All right. Thank you. And we're all here. I'm sure you're happy to know that. You're actually here. Congratulations. All right. It is not 52, choose 4. It is not 50. Yes. That was your guess too. Okay. 48. Why would it be 48? Nice try. Random answer. All right. There's 52 cards in the deck, and we're going to subtract off the 4 queens, and that leaves us all the things that are not queens. You could even label it queens and not queens. There's 4 queens, and I'm going to choose 2. And as far as the not, there's all the other cards that are not queens, and I'm going to choose to get how many of those? 3. And what's this part? What's that plus that make? 52 total. And what's that plus that? That's my 5 out of my 52. It'll always be like that. Now, if you're asking, but it wasn't like that before, watch. There were 13 hearts, and I chose 4. And there were 13 diamonds, and I chose 1. And technically, there were 13 of the other cards, and I chose 0. And there were 13 of the last kind of card, and I chose 0 of them. And then if you add them all up, this, and this, and this, and this will add up to 52. And that, and that, and that, and that add up to 5. So yes, they will always work. Kind of forces the issue. All right, try this one. Go to the next page. And this one I'm going to ask you to hold up and show me in a moment. Okay, wait a minute. You wanted the answer for the other one? The other answer for this one was this right here. If you want to know what numbers that is, when you do 4, choose 2, and 48, choose 3, and multiply them, you get 103,000. All right, good. Moving on. Try this one. It's not that bad. It's not that bad. Just multiply choices. All right. Here's how I do. 1 for the hearts. 1 for the diamonds. 1 for the spades. It's kind of hard to draw. And 1 for the other thing, and I bet a lot of people would have forgot that. See, there's 13 hearts, and I'm going to choose 1 of them. There's 13 diamonds. I'm choosing 2 of them. Diamonds. There's 13 spades, and I'm choosing 1 of them. And then there's 13 other cards. Which should I name? Hearts, spades, and clubs, right? So the clubs, kind of like that. And the clubs, 13, and I'm going to choose how many of those. Nope. Because, look, I only got 1 card, 2, 3, 4 cards so far. It's a 5-card game, so I have to choose 1 of those. Now, all the things I circled there will add up to 5. All of these add up to the other, which is all of them, which is 52. And it ends up being 52, choose 5. Now, that would have been what you... 52, choose 5 is all the different hands that could have been dealt. And this is certain kinds of hands. So if I wanted to make this into a giant probability problem, I'd say, what's the probability of that happening? You got it. Divide it by that if you want to make it probability. Okay. This problem was not a probability question. I was just showing that on at the end to show you what you would do. The final answer would have been 171,000. All right. Somebody's got it figured out. Okay. That's what your homework is about, that kind of stuff. I want to give you 1 more. I want to make this seem more real to you. Let's say that we are playing cards for you to, and if you win, you have a chance to have less homework. Okay? Just this. So, if I have 1, 2, 3, 4, 5. Okay, if I have a 5-card hand here, then what's the probability you would guess correctly which 5 cards they are? Well, there's only 1 set right here. So it's 1 out of, and then how do you do the bottom part? Probability of guessing the hand I have is 1 out of what? Yes. Yeah. Very good. So you have 1 less problem of homework to do then. And if anybody can actually guess the actual cards that I have right here, write them down on your iPad. Write down the 5 cards you think you have. I'm not too worried because there's only a 1 in about 2.5 million chance of anybody guessing right. So just note you have to guess, like, I think it's the 7 of spades and the... Is that what you had? That is weird. It's not, no fair mentally connecting with my brain and using telepathy. There's no 13. Shh. Okay, write them down. All right, I'll show you how quickly your 5 cards will probably get knocked out here. Just think about this. What is the probability that you even guessed the first card right? Nope, doesn't have to be in order. If it had to be in order, these would be a P, not a C. Don't sell the crowd. If you cheated and looked, don't sell the crowd. Okay. So, if I were to tell you 1 of these cards, do you get that there's only a 1 in 52 chance that you guessed that card? So out of this whole room full of people, there's probably not even somebody who's guessed the first card right. You get what I'm saying? There's 26 of you or so the odds of somebody picking the 5 of hearts. All right, so 1 person has the 5 of hearts. Okay, 5 of hearts. A lot of you had 5 of hearts? All right, now, so who am I left with that still have a chance to have all 5 right? All right, so remember, there's a 1 in 2.5 million chance that you're going to be right. Next one is 5 of clubs. That's it. Sorry, they're out. Okay. It was 4 5s and then a 9. All 4 5s. 9 of diamonds. All right, so let's work on your homework. It'll be found under Schoology. It's today's date, assigned on 2-6. I think it's called B. I think it's called 12.6. Is it B or is it 12.6A? Oh, I hit snooze. Yeah, I already have taken attendance. I shouldn't hit snooze. I gotta find a way to, like, kill it instead of just snoozing. I think I'm still recording. I'm gonna stop now.